All right. Here's our functions and equations lesson. So go ahead and get the start of your page ready. Get your title up top. Then get your learning target and your learning standard. And then our all-important I can statement. By the time we're done, you should be able to go back and look at this and say, yes, I can write an equation to represent one of our functions or tables. In our lesson from right before break, we talked about functions, and we used the function. Basically, it was a rule for how to transform our inputs into our outputs. So it might be something like whatever number you plug in, you add 13, or maybe you multiply times 7. Basically, it was just a rule for transforming from one to the other. Well, we can use that same idea to work backwards. If we already have our table of values like we do here, we can use that to work backwards and figure out what was the function or what was the rule that we were using. To do that, we take a look at our inputs and try to decipher what happened to them to turn them into our outputs. So in this case, a 7 became a 12, a 9 became a 14, and a 28 became a 33. Well, to get from 7 to 12, the only thing that really comes to mind is you could add 5. The key is you got to use that exact same rule for everything else. That's the only way it can be your function, is if it works for all of the inputs. So if I take a 9, if I add 5, do I really get 14? Yeah, I do. To get from 28 to 33, can I just add 5 to get there? Absolutely. So that means my rule is I'm simply adding 5. So now that we know the rule, let's put it to use. If I plug in 47, I want to add 5. 47 plus 5 is an output of 52. If I plug in 86, and again I want to add 5. 86 plus 5 is 91. This one I got to work backwards. So what did I plug in? I added 5 to it and got 100. Well, 95 plus 5 gives me 100. So just knowing a couple of the inputs and outputs, your x's and your y's, can help you figure out what was the function that you were using, what was the rule, so that you can kind of use it to work backwards and find some additional values. All right, a little vocabulary to fill in. On our first video on functions, we talked about the inputs and the outputs. The inputs are our x's, our outputs are our y's. You plug in the x, you do something to it, and out spits the y's. But another name for them are independent and dependent variables. Independent meaning you get to choose it. No one's deciding it. You decide what you plug in, or we give you some numbers to plug into it. The dependent variable is your output. The dependent variable is completely controlled by the function. It doesn't have any choice. You plug something in, you have to follow the rule. It spits out a particular output. So it depends on what you plugged in terms of what you got back out again. Here is our focus for today. We want to be able to write each of these functions, each of these rules, as an equation, which means it's going to look something like y is equal to something involving x. But basically, a good way to think of it is, what did they do to x to get to y? What's our rule? We're just going to write it in kind of a formal fashion. So to do that, look at your pairs of inputs and outputs, your x's and your y's. What do I do to 1 to get to 9? Well, I could add 8, or I could multiply times 9. So I need to figure out which one also works for the other numbers. So from 2 to 18, well, I definitely couldn't just add 8, but multiplying by 9 definitely works. From 3 to 27, I could multiply by 9. From 4 to 36. So my rule is I'm just multiplying times 9. So we need to write that in an official form. So basically, what did they do to x? Well, they took x and they multiplied it times 9 and got y as an answer. So it's always going to be something done to x equal to our output of y. Take a look at this one. We go from a 1 to a 16, a 2 to a 32, a 3 to a 48. So from 1 to 16, I could either add 15 or I can multiply times 16. Looking at our other pairs of values, to get from 2 to 32, it definitely looks like multiplying times 16 is the way to go. So again, we need to write that as an equation. So what did they do to x? Well, they multiplied times 16. 16x means 16 times x, and it's equal to y. You can put the equal to y either at the beginning or the end of your equation. It doesn't matter. But it's just kind of a formal way of saying, okay, here's how I get y. I do this to my inputs, to my x's. So let's put this to use. If you think you've got a good handle of this, you think you know how to do these, go ahead, pause, write down each of the tables, and then write your own equations. If you're not quite sure how to tackle it yet, follow along with me. We'll do a couple of them together, and then if you're ready for it, jump down to the end and try to finish it. Just know, going in, this last one's going to be a little bit on the tricky side. So let's take a look at our first one. We want to know, what did they do to x to get to y? So what did they do to 1 to get to 3? Well, they could either multiply times 3, or they could add 2. I don't know yet, so I got to use some of my other values to find out. Well, to get from a 2 to a 4, well, multiplying by 3 is not going to work. Adding by 2 does work. How about from 3 to 5? Well, from 3 to 5 is just adding 2. So to write our equation, we always ask, what did they do to x? Well, they added 2 and got y for an answer. So our equation is x plus 2 is equal to y. Over here, to get from 0 to 0, well, there's a whole lot of things I could do. I could add 0. I could subtract 0. I could multiply times 0. Okay? I could do any number of things to get from a 0 to a 0, so that doesn't help me very much. So let's look at our other numbers. To get from 1 to 4, well, I could either multiply times 4, or I could add 3. Well, to get from 0 to 0, if I did 0 times 4, is that still equal to 0? Yeah. If I did 0 plus 3, would that still be equal to 0? No. So let's check one more pair. To get from 2 to 8, does it work to just multiply times 4 to get from 2 to 8? Yeah, that works. So what did we do to x? We multiplied times 4, and that got me an answer for my y. So that's how I write as an equation. Hopefully you're starting to get the hang of it. Next one, we got some decimals. Doesn't mean they made it that much more complicated. It just means you got to be a little bit more careful with it. So look at your x's. What do they do to get to the y's? So always kind of look at them in pairs, the x and y's together. So to get from 1 to 0.5, so they went down by 0.5. So I would think of it as subtracting 0.5. Let's see if it works here. From 2 to 2 down to 1.5. Well, it looks like they subtracted 0.5 again. From 3 down to 2.5. So think of it kind of like $3 down to $2.50. They subtracted 50 cents. So our rule is, what did they do to x? Well, they subtracted 0.5, or you could put it as 0.5 if you want to be proper. And that gives us our y. Okay. Let's take a look at another one. I said this one's going to be the more challenging one. We need to get from a 2 to a 5. Well, the easiest way to get from a 2 to a 5 would be to multiply, or just to add 3. So let's see if that works. Can I get from 3 to 7 just by adding 3? No, that doesn't quite work. How about from a 4 to a 9? Does that work? No, that doesn't work. Can I get from a 5 to an 11? No, just adding 3 is not going to quite cut it. This problem involves a two-part problem. Usually that means you're either multiplying or dividing, and then you're either adding or subtracting. You're kind of doing two things to your number. So think about, how would I get from a 2 to a 5? Well, I could multiply times 3. 2 times 3 is 6, and then subtract 1 to get to 5. So let's see if that works here. 3 times 3 is 9. Minus 1 is, well, it's not 7. So that doesn't work. So another try. Well, what if we get close to 5 but not quite there? So what if we multiply times 2? 2 times 2 is 4, plus 1 more. That gives me to 5. So try it with a 3. 3 times 2 is 6, plus 1 is 7. 4 times 2 is 8, plus 1 is 9. So it looks like my rule is working. So again, what did we do to x? Well, we multiplied it times 2, and then we added 1. It was a two-step process, but that gives us our y for our answer. Okay? That'll be about as challenging as we'll see, but it's definitely something that you got to work for. If you can't find a nice simple, they added or subtracted something, or they just multiplied, look for that two-step process there. So, we're all done with the video. I want you to copy down these two problems and try them on your own. Write an equation to represent each one of these function tables. Again, compare your x's and your y's and try to come up with your rule for how do I get from one to the other. Just remember, whatever rule you come up with has to work for all of the pairs of inputs and outputs. The first one over here, this one should be pretty straightforward, pretty easy. The second one is going to be like that last one we just looked at. A little bit tougher, a little bit more complicated, but give it a try and we'll talk about it in class tomorrow.